The substrates approach the enzyme and connect to it, forming the active site. The substrate binds to the enzyme, forming the enzyme-substrate complex. The substrate now forms into products. The products are then released. In competitive inhibition, the competitive inhibitor competes with the natural substrate for the active site. This is reversible because the enzyme's character is not fully changed. When the concentration of the competitive inhibitor is reduced, the active site is less likely to be occupied by the inhibitor. When the concentration is reduced, the enzyme regains its normal activity. The non-competitive inhibitor binds to an enzyme at a site distinct from the active site. This binding causes a change in the shape of the enzyme that alters its activity permanently. Allosteric regulation occurs when a non-substrate molecule binds or modifies a site other than the active site of an enzyme, called the allosteric site, inducing the enzyme to change its shape. The change in shape alters the chemical attraction of the active site for the substrate, and so the rate of the reaction is changed. Allosteric regulation can result in the activation of a formerly inactive enzyme or the inactivation of the enzyme. Additionally, a new product may be made. A paradigm example of this would be when oxygen binds to hemoglobin. Feedback inhibition is where the final product of a reaction, in red, then binds to the commitment enzyme, in brown, making the whole enzyme reaction, including the blue enzyme on the right, inactive. As the substrate attempts to bind with the enzyme, heat influences the shape of the enzyme, denaturing the active site and stopping the substrate from binding. As you can see here, the shape of the enzyme will change, and the substrate will not be able to bind.